Hi, in this video we're going to continue proving trig identities. We're going to talk about example 3 and example 4, which get a little bit harder than example 1 and 2. So let's take a look at example 3. In example 3, we need to prove that cosine over 1 minus sine equals 1 plus sine over cosine. I want you, whenever you see 1 minus or 1 plus sine or cosine as a denominator, to think about the special case. And let's review the special case together. One of the important special cases is a minus b into a plus b equals a squared minus b squared. So if we have one factor, we can multiply top and bottom by the second factor. That way we get squared. And how does that help? When you get squared, remember you can use the Pythagorean identities, and that's the whole purpose of this. Pythagorean identities, especially with sine and cosine, you can change a sine into a cosine and a cosine into sine if you have them squared. So for example, if you end up with sine squared, it's nothing but 1 minus cosine squared. And if you get anywhere 1 minus sine squared, it's equal to cosine squared. Let's see how this will work right here. So I see 1 minus sine. I'm just going to take the left side as we agreed in previous videos. Make it, change it, manipulate it using algebra skills and trig identity until we make it look like that second side or the right side. So we have to keep an eye on the right side. I'm going to take this and I'm going to multiply the top and bottom by 1 plus sign. You might ask, how would I know I need to do this? This comes with practice first. And second, I am giving you a hint that we're heading toward using one of the special cases. Equals. So I'm going to leave it as cosine x parentheses 1 plus sine, and I'm going to apply that special case on the denominator. You can distribute 1 minus sine and 1 plus sine in the traditional foiling way. I do not recommend that. You highly need to know the special cases. You're highly recommended to use the special cases. So divided by a squared minus b squared, which means first term is squared minus second term is squared, and 1 squared is just a 1. And you can see now how useful this is. I got 1 minus sine squared. If I check my trig identity sheet, specifically Pythagorean identity, because I see the square, 1 minus cosine squared equal sine squared, and 1 minus sine squared equal cosine squared. So I can substitute the denominator with cosine squared, and I'm just gonna recopy the numerator. That way, it's gonna allow me to simplify top and bottom. The cosine cancels, the square goes away. Some of you were wondering how we could do that. You can go back to the rule of when we divide, we subtract exponents. If you also like to show the work, t divided by t squared, write t multiplied by t, and you can see how this cancel out. Similarly with cosine, if you have cosine over cosine squared, it's cosine over cosine times cosine, and those cancel out. You'll be left with 1 over cosine. That's what's going to happen here. We are left with cosine on the denominator and 1 plus sine on the numerator. And let's take a look at what we needed to prove, and we just proved it.